Hello students, in the previous video we have seen the basic operational concepts related to computer organization. So we are discussing about the module 1 topics. This is the diagram represents the interrelationship between or the connection between the primary memory or main memory and processor. Memory and processor. Those who have not watched the previous video, please watch it again and make a note of it. The various registers, as I told you earlier, register is a tiny memory unit of which is contained by the processor itself. Okay, and the register and memory locations are different. Memory locations, memory is the separate module, independent module, which is the isolated part, whereas register is belongs to the processor itself. It is used, registers are used to store the intermediate results, while processing the data it is to be stored somewhere, isn't it? That is the reason why registers are used inside the processor. There are two categories of registers. One is special purpose and the other one is the general purpose. Special purpose registers are listed here: MAR, MDR, PC and IR. They are called as the special purpose registers, where MAR stands for the memory address register, which stores the address of the instruction or data which is being executed, and PC is once again an address register only, and this stores the address of the instruction which is to be executed in the next iteration, in the next interval of time. For example, in a sequence you are asked to answer for the question in a sequence. Serial number 1, let me start with the serial number 1 or USN 1 followed by USN 2 followed by USN 3 and so on. If I follow that sequence, you will come to know when your turn will come, isn't it? Right? So you will come to know when your turn will come. So whenever USN 1 is being answering, USN 2 will be ready to answer either for the same question or for the different question, right? That USN 2, that number 2, that will be stored where? In program counter. Try to analyze the concept. I am correlating the real world scenario with computer organization concepts. If you correlate this with the real world scenario, then only you will understand easily. Please concentrate carefully, watch the video, pause and watch the video again, rewind the video. If you still have any confusion, what is that? If there are 10 members, assume, and you will be asked to answer for certain questions sequentially, one after the other, USN wise. So whenever USN 1 is being answering, USN 2 will be ready to answer, isn't it? Right? That USN 2, that is what your address. Yesterday we have discussed about in the previous video we have discussed about the addressing, right? What is addressing? Each and every person will be having an identity or address. Similarly, in case of computer science, the data, each and every element of the data should be identified easily in terms of bytes. They are called as addressing, right? It's a location value. It is what called as the addressing. So that address value is stored under a register called as MAR. What is MDR then? Corresponding data. MAR is the address value, your USN or whatever. What is the data then? What exactly stored in the particular location is called as data. What exactly stored? Your USN is what? You may be 12 CS, 18 CS or 19 CS 001, whatever your USN is, right? What is your name or what exactly the content you are going to, from where to access? It is to be accessed from another register. What is that? MDR. Getting no? PC is what? PC is the one I told you earlier. Whenever USN 1 is being answering, you will come to know what is the sequence. It is the sequential order I am following. USN 2, right? Right? That value will be stored in PC. And instruction register, which stores some certain kinds of instruction, arithmetical and logical instructions. Those instructions will be normally in assembly language or any other programming languages, okay, where machine will understand its meaning. That instruction is nothing but what type of operation to be performed. Normally use a computer for addition, subtraction, multiplication, division, or any other kind of logical operation as well as arithmetical operations, isn't it? Right? So what kind of operations to be performed, that is identified by IR or instruction register. So MAR, PC, IR and MDR called as special purpose register, whereas R0, R1 till Rn minus 1, where you can see here which I am highlighting, they are called as N general purpose register. Apart from them, processor will be having control unit as well as arithmetical and logical unit. Arithmetical and logical unit is identified as ALU. Its job is to perform the arithmetical and logical operations, whereas control unit CU, which governs the path of the data flow. And you can see the bidirectional arrow and unidirectional arrow. This tells you about the path of the data, from where to where data transferring is done. From MAR towards memory it will be, and between memory and MDR it is bidirectional. Between memory and control unit again it is bidirectional arrow. This arrow mark is also called as bus. Again correlate this with real world scenario. What is bus? It's a carrier which carries passengers from one place to other place. Here with respect to computer science, that computer organization, this concept, what do you mean by passenger? Data itself is a traveler or passenger, right? Who will carry them? Data will be traveled between processor and main memory with the help of whom? With the help of bus. Okay. Now read the statement which are mentioned in bold letters carefully. Following are the steps that take place to execute an instruction. See the instruction: load LOCA, R1. Second instruction is add R1, R0. So load LOCA, R1 is the first instruction. Add R1, R0 is the second one. Read the statements. See these are the steps takes place to execute the instruction. These instructions are there in it is not a C programming, a programming called as assembly programming. LOCA is a location identity, R1 is a register, general purpose register. R1 and R0 are the general purpose register. The meaning of the first instruction is load the value stored at location. What is the meaning of the location? Identifier is LOCA, right? And store it in R1, general purpose register. Then add the content of R1 to R0. Add the content of R1 to R0. Where it will be stored? It will be stored in a location R0 itself. Add the content of R1 to R0. Store it in R0 permanently. The address of first instruction to be executed gets loaded into PC. So for the first time, the address of the next instruction itself is the first instruction, that is load LOCA, R1. Its address value will be loaded onto the PC program counter. Next step is step number 2. The content of program counter, the address value, are transferred to now LOAD, that is load LOCA, R1. This is the instruction which is being executed, so it is to be transferred on to MAR, right? Try to analyze and try to understand. This is the instruction which is being executed. Its address value will be loaded onto MAR. At the same time, PC is the, normally it contains what? Who is getting prepared? The second instruction is getting prepared. Whenever USN1 is being answering, USN2 will be prepared for the question, right? In the same way, the second instruction address. What is the second instruction? Add R0, R1, R0, right? That is what the second instruction. Just go through, watch the video again, note down the things, okay? So step number 3, you observe, after certain amount of lapsed time, the first instruction is read out of memory and placed onto MDR. The contents of the first instruction, that is load instruction, load LOCA comma R1 is the first instruction, its content will be placed onto MDR. Next, the content of MDR transferred to IR. At this point, the instruction can be decoded and executed. So the role of IR, instruction register, which tells you what to perform, which will decide what to perform. What to perform in the sense, whether it's an addition, subtraction, copy operation, deletion, or whatever the operation it may be, right? Next, the contents of MDR transferred to IR. That's what the fourth step is. Decoding in the sense identification or identifying as well as deciding by the processor what action to be taken. Step number 5, to fetch an operand, its address is placed into MAR and control unit issues a read signal. As a result, the operand is transferred from memory into MDR and then it is transferred from MDR to LU. Just try to understand the statement. Likewise, required number of operands fetched into the processor. Finally, LU performs the desired operation. If the result of this operation is to be stored in the memory, then the result is sent to MDR. From MDR, it will be transferred onto the memory. Check the arrow mark or follow the arrow mark. The address of the location where the result is to be stored is sent to MAR and a write cycle is initiated. Say about the read cycle and write cycle, don't get confused much. You will be you will come to know what exactly the meaning of that read operation and write operation subsequently in the next topics of the same module as well as in the next modules as well. So no need to get confused or no need to worry about those topics. So let us see them in detail about the read cycle and write cycle in the next sessions. But try to understand the steps, observe the steps carefully. So in the next session, let us see what is the meaning of bus, and anyhow the meaning of bus we have discussed already. What is the bus structure? What do you mean by single bus? Okay, this is what single bus structure is. Let us see them in the next session. Thanks for watching.